I'm Mr. Richmond, and this is your Unit 12.4 lesson summary. In Unit 12.4, we'll take a look at parallel and perpendicular lines on a coordinate plane and approach a few different problems in regards to that. So the first thing we need to know to start the session off is what a parallel line is. We've seen that before, but just to review, parallel lines are lines that never cross or never intersect. And for that to happen, they have to have the same steepness, which means they have to have the same slope. So super important we know parallel lines always have the same slope. Perpendicular lines we've worked with a little less, but those do intersect, but they intersect at a special angle, a 90-degree angle, a right angle, a square angle. In order for that to happen, the slopes then have to be what we call opposite reciprocals. Opposite meaning different signs. If one slope's positive, the other has to be negative. Reciprocal being flipping the fraction. So if this slope was 2, which is 2 over 1, it would have to be opposite, so negative, and reciprocal, which is 1/2, because 2 over 1 reciprocal is 1/2. If the slope was negative 2/3, then my perpendicular slope would have to be a positive 3/2 as it flips. So the problem I'm going to do with you to kind of show this and let you see problems that might be on the test in regards to this is I'm going to give you a few different lines. So I have lines P, Q, and we'll call this one R. And I want to find out if they're parallel or perpendicular to each other. So we're going to kind of compare all of them. But I need you to provide me with evidence. And the slopes are going to be the evidence, because if the slopes are the same, then I can prove that they're parallel, because that is a rule in math. And if the slopes are opposite reciprocals, then I can prove they're parallel, also a rule. So I can't just say, oh, they look parallel. So what I'm going to do to prove they're parallel is find their slopes. So I'm going to start by finding the slope of line P. And I do that using y2 minus y1 over x2 minus x1. So line P, I'm going to do y2 is 6, y1 is 0, so 6 minus 0, over x2, which I'll make 0, minus x1, which is negative 3. And when I minus a negative, I need to be ready to zip zap. So I end up with 6 over 3, which is 2. So the slope of line P is 2. Let's compare that to line Q. So I'm going to find the slope of line Q. And again, I could do rise over run or the formula. So if the points work for you that way, you can just add up and over and find your slope that way. That is an option. I think for this one, I'm going to stick to using the slope formula though. So I have negative 2 y2 minus negative 10 over 4 minus 0. Negative 2 minus 10 would zip zap to plus 10, leaving me with 8 over 4, which leaves me at 2. So now I know that slope of line P and the slope of line Q are the same. They both have 2, which means they should be parallel. And although my artistic skills are lacking, they are relatively parallel for what I drew here. Now let's find the slope of line R. Again, I could use the formula for slope, or I could do rise over run if I felt the need to count it. It's kind of my call. I could go down and over if I have a good enough graph. So I'm still going to go with the formula because I like that the best. But if you trust yourself counting and you can keep track and you don't mind writing over your graph, you can do that. So I'm going to go y2 is negative 2 minus y1, which is positive 2, over x2, which is 4, minus x1, which is negative 4. I have minus a negative again, so I zip zap. Negative 2 minus 2 is negative 4. 4 plus 4 is 8, making that slope negative 1/2. Now as I look at it, these two are parallel because their slopes are the same, and negative 1/2 is opposite of 2 because it's positive and negative, and the reciprocal of 2 is 1/2. So it is an opposite reciprocal to both of these. So now I can start to make my statements. Lines P and Q are parallel because their slopes are the same. And I have the proof above it to go with it because I showed the work for the slopes. And then inversely with that, I can say line R is perpendicular to lines P and Q because their slopes are opposite reciprocal. And my slope math above verifies this answer. Okay, so we do need to make sure we're providing that explanation via work and also explaining in words why our answers are parallel or perpendicular. So hopefully that helps there. The next problem is a tough problem, I'm not going to lie here. There's a few steps, but I'm going to try to break down into two separate topics for you. So what I want to do now is write the equation of a line perpendicular to a particular line passing through a point. So I'm going to give you a quick visual. What I'm doing, and this isn't for necessarily this problem, I'm just going to show you kind of a random problem, but I have a line, I have a point somewhere, and I want to come up with a line that's perpendicular to that, passing through that given point. So all I'm going to know is the point, and I'm going to have to use my rule of slopes. If I know the slope of this line, then I know the slope of this line has to be opposite reciprocal. So I can use that law to give me the slope of this line, and I'll have a point and a slope. And with a point and a slope, I can use point-slope forms to then write the point-slope form of the equation. That's how I'm going to approach that. I can also do this for parallel. If they gave me a line and said I want a line parallel to this line going through this point, I could do that as well, because I know that if they're parallel, then this line has the same slope, so I'd use the same slope in the point, plug in a point-slope form. What's going to be a little different about this problem is we're going to do two steps. We're going to find the equation of a line perpendicular to it, passing through a point, and then we're going to try to measure and find the distance between the line and the point. And whenever you measure distance, you want to do it at a perpendicular angle because it'll be the shortest distance. So it's going to involve a little extra work because I'm going to need to figure out an intersection point as well. And to find an intersection point, I've got to use a system of equations. So there's going to be a bit of work involved here. And hopefully we can handle it. So let's give it a shot. So let's write the equation of a line perpendicular to y equals 4/3 x plus 2 passing through negative 4, 5. Now, because it says perpendicular, I can figure out the slope of this unknown line. It should be opposite reciprocal compared to this slope 4/3. So I'm going to make it a negative 3/4, and I know that it has to pass through the point negative 4, 5. I have everything I need to write an equation of a line. I have a point and a slope. So I'm going to use point-slope form. Y minus y1 equals m times x minus x1, and x1 is negative 4. And if it's negative 4, it'll zip zap to plus 4. At this point now I can distribute it, try to put it in slope-intercept form, so that's probably the form we in here are most comfortable with. Negative 3 times 4 is negative 12, negative 12 divided by 4 is negative 3. Then I add 5 over, and my final equation would be y equals, make sure that plus 5 going over for you, negative 3/4 x plus 2. So that is the equation of a line perpendicular to the given line passing through a point. And I can do this exact same thing if they said parallel by, instead of using this slope, just using the same slope. So it would look almost identical, only I'd have the slope of 4/3 written in there rather than the opposite reciprocal slope. So you can do both styles of that problem. Now what I want to do is, now that I have the two lines, I have this line and this line, and I'm going to want to find this distance. Well, in order to find a distance, I need 2 points. I have this point. I don't know this coordinate yet, but I can find it because it's the intersection of the two lines in the problem. And to find the intersection of two lines, you use a system of equations. So I'm going to take the two lines, and I'm going to write them as a system. 4/3 x plus 2, negative 3/4 x, also plus 2. And now I can try to solve that system. So let's give it a shot. Now it has fractions. It's not the nicest looking thing, but I can do substitution because it is isolated for a variable. So I'm going to take the 4/3 x plus 2, plug it in, Rewrite the equation, 4/3 x plus 2 equals negative 3/4 x plus 2. I'm going to add the 3/4 x over to this side. And while I'm at it, I can subtract the 2 over here and see what I get. Now on the right side, I'm going to get negative 2 plus 2 is 0. On the other side, I'm going to get 4/3 x plus 3/4 x. And although it's going to be set to equal, it's actually going to make this a little bit easier. Let me show you how to add these. I need a common denominator, multiply by 3. So I'm adding 12/3 x plus, multiply by 3 over here. Or sorry, what's that up? Multiply by 3 here, or sorry, 4 here gives me, because I need a common denominator of 12 on the bottom. Multiply by 4 here is 16, over 3 is 12. Multiply by 3 here is 9, over 4 times 3 is 12. And I'm adding 16/12 plus 9/12, which is 25 over 12x. So to isolate the variable, I multiply by the reciprocal. And again, none of this is going to matter right now because it's going to be multiplied by 0. My x is going to equal 0, but it's good to review how to do fractions. So I have my x is 0, and just like when I did systems before, all I have to do is plug that back in to one of the originals. 4/3 times 0 is 0, 0 plus 0, or 0 plus 2 is 2, and I have the intersection point now for those 2 points. So, now that I know where the 2 points are and what they are, all I have to do is use the distance formula and find that distance. So I'm going to use the distance formula for the points negative 4, 5 and 0, 2, and I am clear and free to go. So the distance is x2 minus x1. Let's do it that way. For our distance formula, x2 would be 0 minus a negative 4 squared plus y2, which is 2, minus 5 squared. Simplifying that, 0 minus negative 4 is plus 4. 4 squared is 16. 2 minus 5 is negative 3. Negative 3 squared is 9. So the distance between these points is the square root of 16 plus 9. The square root of 16 plus 9 is 25. So the distance between that point and our line is 5. So a lot of steps there. It can be a little bit tough, but if you stay, diligent and really push at it, you can do this problem. It will be broken up into steps. So hopefully, even if you can't get the whole thing down and get the distance, you can at least get that perpendicular line or a parallel line passing through a point. All right, thank you and good luck.